Section 8.6 is the tangent function. Our goal is to graph the tangent function. On page 619, we have the tangent function is closely associated with the sine and cosine functions, but it differs from them in three dramatic ways. The tangent function has infinitely many points of discontinuity with a vertical asymptote at each point. Its range is all real numbers, its period is pi, half that of both the sine and cosine functions. Its domain is all real numbers except odd multiples of pi over 2. Suppose the terminal side of an angle theta in standard position intersects the unit circle at the point xy. Then the ratio y over x is the tangent of theta, denoted tan theta. In this diagram, x equals cosine theta, y equals sine theta, and y over x, or sine theta over cosine theta, equals tangent theta. Example 1 for part A says what is the value of tangent of pi? Do not use a calculator. And part B says what is the value of tangent of negative 5 pi divided by 6? Do not use a calculator. First, remember that xy relates to cosine theta sine theta, and that tangent theta is sine of theta over cosine of theta, which is y over x. If we sketch a graph of pi in standard position, we can see that we will land on negative 1, 0 when pi intersects the unit circle. This gives us an x value of negative 1 and a y value of 0. Therefore, we have tangent of pi equals 0 divided by negative 1, or 0. For part B, if we sketch negative 5 pi divided by 6 in standard position, we'll get this graph. We can use this little triangle in the third quadrant to note that we have pi over 6 left right here to get all the way over to negative pi. Pi over 6 is the same as 30. Since we drop a perpendicular down, we'll have a 90-degree angle here, so 30 and 90 leaves us with 60 for the other angle. So we have a 30, 60, 90 triangle. We have a reminder that a 30, 60, 90 triangle that you learned about in Math 2, the short leg is going to be 1/2 of the hypotenuse. Here our hypotenuse is 1 because we are dealing with the unit circle, and the long leg is going to be the square root of 3 times the short leg. So 1/2 of 1 gives us 1/2. And square root of 3 times 1/2 gives us the square root of 3 divided by 2. These give us our x and y values for where the standard position of negative 5 pi over 6 will intersect the unit circle. Since we are in the third quadrant, both values should be negative. So we have negative square root of 3 over 2 for our x value and negative 1/2 for our y value. Since tangent of theta is y over x, we'll use negative 1/2 divided by negative square root of 3 divided by 2. Since we are dividing fractions, we can rewrite it horizontally, and then we can switch the sign of multiplication and flip our second fraction. This gives us negative 1/2 times negative 2 divided by the square root of 3. The 2 on top and the 2 on bottom will become a 1, and we're left with positive 1 over square root of 3. However, this is not simplified because we need to rationalize the denominator to get rid of the square root in the bottom. So if we multiply the top and bottom by the square root of 3, we're really multiplying by 1. This gives us the square root of 3 over the square root of 3 times the square root of 3, or 3. Therefore, tangent of negative 5 pi over 6 is the square root of 3 over 3. The work for this problem is written out on the next few slides. And now I would like you to try number 1. Find each value without using a calculator. Tangent of 2 pi.